Well, I've got everybody here. The reason why I don't want you to open the bags is because inside the bag are two very small screws, okay, which I cannot replace because they go on, they screw the wheel onto the hub, and they only gave us exactly the number of screws for the number of wheels. Yeah. So if you lose it, we got problems. So, I'm sure they'll be down in the bottom, but be on the lookout for them because, that's what they are. The other thing that's in there is a chip. Okay, it's wrapped in aluminum foil. Okay, don't mash it around too much. Okay, if the pins are bent, we can straighten the pins. That's not a problem. But be on the lookout for the aluminum. Okay. So what we're going to be doing today, if everything works out, and it should, is now in order for that to do that simple program, we have to get all the electronics and mechanics put together. Okay. And what?
And some soldering.
Okay, and yet, as Chuck here mentioned, we have to solder 4 joints here on the motors. So tonight's going to be soldering and mechanical assembly. So now you're welcome to open up your bags of stuff, watching very carefully for the screws, which are going to be in the bottom. So the big piece of pegboard is your base. Okay. And then you've got 2 metal wheel brackets. They're deep, they're very small.
We'll be working on today.
And very small screws are going to be at the bottom of that bag.
Here's the circle.
So I'm going to briefly borrow these. Okay. These are the wheel brackets. Okay. These are actually the hardest part of the whole project for me because I wanted to just buy some wheel brackets over the counter, and I just didn't like the ones that were available. So I wound up making these. Okay. And just for amusement, what I discovered is that we ordered the wrong thickness of angle aluminum. And so when I made the first bracket, the wheel didn't fit on it, rubbed against the thing. So I had to put this on my mill and remove basically 1/8 of an inch of metal from one surface of this. Okay. So if you see these pretty patterns, that's an end mill that was just removing a lot of metal. Okay. So these are the brackets, and we're going to be putting the motors on. But before we put the motors on, we have to solder on the wires. Okay. Now, before I forget, there is 2 pieces of handout today. Hand that down. One of them is our assembly. Just please take one per kit, okay? One of them is our wiring diagram. Now, let me talk about soldering. So, one of the reasons why the Arduino is so popular is because with a protoboard, patch cords, and a breadboard, and the Arduino, you can assemble an amazing number of things without ever having to use one of these soldering iron. Okay? And soldering isn't a super hard skill to acquire, but it's a little scary. You can burn yourself. So if somebody ever hands you a soldering iron like this, you're supposed to step back and say, no, no. You never pick up a soldering iron from this way. I won't even show you how to do it wrong because I did it once.
If you do it, you'll only do it once.
You will only do it once. I did do it once in my lifetime. It was 2nd-degree burns, and it took 6 weeks to heal. Okay. So never grab this end. That hurts. And if it's falling, let it hit the ground. Okay, because you don't want to get hurt by grabbing the hot end. Okay. The other thing is when you're handing a hot soldering iron to somebody, you hand it to them like this. Okay. So this is just basic safety.
And make sure that they don't grab the tip.
And if they're reaching for the tip, you take it away. Okay. So that's the real way you can get hurt with these things. Okay. Okay. Now, we have to do soldering because if you look inside the kit, you'll see the 2 white gear motors. Okay, and those need 2 wires soldered onto them. So what we're going to do is we're going to take, for each of the tabs on the thing, there's 2 motors and there's 2 tabs on each motor, total of 4 wires. We're going to take 4 long patch cables and we're going to solder one end of each of those things on each of the terminals. Make for sure you have different colors so you can keep track of what's going on. Now,
Do you want to suggest black and red? Or?
I would prefer not black and red. Black and red should really be reserved for power and ground.
Okay.
Okay. So let me do just a little bit of talking about soldering. Okay. So you've got like a lug on your motor, and it goes to the rest of the motor.
Do you have a darker pen?
You try.
A little tough to see from back here.
That's probably hard to erase, but that's a separate. So this is the motor, and then we're going to have our patch cable thingy, and it's got a wire sticking out like this. And what we're going to do is we're going to bend this like that. Actually, the way we're going to do it is we're going to stick the wire through here, and then we're going to bend it around. Okay? And then we're going to crimp it a little. And then we're going to come in with our hot soldering iron. Okay? And we're going to melt some solder on it. Bye, Julie.
This one.
Okay. So what's the trick on solder? The trick on solder is you need to get a good thermal connection. I mean, we're familiar with good electrical connections, but we're not as comfortable with good thermal connections. Have any of you ever tried to cook on the stove with an old pot where the bottom's concave? Convex. I think convex is what I mean. What happens is it doesn't heat up very well because there's only one point touching on the stove. So with the soldering iron, what we want to do is we want to get connected here. And if we get a good thermal connection, all the heat is going to come flowing down there, and it's going to warm this thing up enough to solder it. Okay. So what we do is we take some solder and we dab it onto the end of the soldering iron. Okay. And we melt a little bit of solder on there.
And if the solder doesn't melt, your iron is not hot enough.
Yeah. If you cannot melt solder on the tip of your soldering iron, stop. you need to get it warm. Okay. So you melt a little on there. And then the trick on all this is you want to get that solder to sort of touch the joint here and the soldering iron, so you basically have what we call wetting. Okay, so this is the solder. And when you have that little piece of molten solder from the tip to what you're trying to do, now the heat can get out of the soldering iron and into the joint to be soldered. And then this will get warmer, and then you can melt the solder onto the joint. So the trick on all of this is you start with a dab of solder on the end of the tip, and then from the rest of it, you melt the solder actually on the joint. Okay? We're going to struggle with this, so I'm planning on spending a fair amount of time doing that.
And you want to make sure that both of the pieces don't move, because if you move, then you get what's called cold solder joints,
Yeah.
and then you don't have a good connection.
Okay.
So you need to make sure they're stuck.
Okay. So this is kind of where, soldering is like the first thing we got to do before we can do the rest of the mechanical assembly, and then we can go to the programming. So it's soldering, mechanical assembly, and then everything else. Okay. If you have something called stranded wire, you're supposed to tin it first, but we don't have stranded wire. Okay. Now, some people have gotten are succeeding. Here's one that's working. Okay. Now, in your bag are something called nylon ties. There's 2 of them, and we're going to put a nylon tie. So here's a nylon tie. Okay, and what we do is we wrap the nylon tie around the wires. The wires coming along this way. And you just want to make sure the wires are on the same side. And then you go through here like this, and you stick it through like that, and then you tighten it up.
And that's so if you pull the wires when you're working with them, it won't rip them off the motor.
Okay? That's just so that you don't break your wires eventually, because it's really a pain in the rear when you break a wire.
Yep.
So that's what you do when you're all done. When you're done with this, now we can go on to the mechanical side of starting to assemble the robot. Pull out your brackets. And I'm going to use yours as a So, the brackets look like this. Okay. Made them in my garage. And the way it all works is there are these 1-inch 440 screws, and they are going to go next to this big slot here. Then the motor will fit over the 2 screws like this, and the hub will go through.
So it's on the inside of the L?
Inside of the L, yes.
Okay.
Okay. And the wires are going to be facing out from the L. Okay, people, we're getting closer to the next phase, construction, which is attaching the wheels to the base.
Yes, you did. No, that's.
I don't have anybody's attention. Okay, so I can borrow your. So these are going to go on like this, and it's going to be held on with 2 screws. Actually, if you want, you can put 4 screws on there, but that's complete overkill. And I would put it so that there's 1 blank row of pegs in front of your robot. Okay. Okay. And the way we're going to do that is it's going to be a number 6 screw. There'll be a washer. Let me draw it on the board. So we're going to have the screw. It's going to be a washer. Then there'll be the pegboard. There'll be another washer. There'll be a lock washer. It'll have teeth on it. And then there'll be the nut.
Okay.
Okay. And this hole's bigger than the screw. And the reason for that is so that you have some room to slot things around. So that's quite deliberate, having the oversized hole and the smaller screw. Okay.
Depends on where the screw goes. I'm assuming it goes here.
This
Or
is
you think it goes underneath?
I don't know.
No, he has it going here. I think
Well,
that's probably correct.
That, not necessarily.
But he didn't countersink it, so that's why I
Nancy,
said there was...
are the screws supposed to go the way you have them or the other way?
Where in the other one, I've not seen you.
for the wheel thing, we don't need the second washer. The purpose of the washer is so the screw doesn't
Before you undo this one, you put the other one in when you want it. Before you undo this.
An old male, no, at the lab. He belongs to Tech Shop. You heard of that? Yeah, my husband has a membership to that. He does his building. I'm more the manager type, not the builder type. Yep. I'd like to get back to it.
Yeah, that's true. Silicon Valley is a lot more free.
I haven't done any hands-on since I was in engineering.
That's sort of the back country.
I don't know, these supposed to go in the short? They're supposed to go this way?
So the caster cell end
So we need 2 nuts.
with two screws pointing up,
Okay, yours
and then a rubber band goes around, through, and back.
we got 1 lock washer and 2 washers. So no nuts, but we've got the bolts.
So, okay, the next thing, as more and more of you are getting the casters on, the next thing we do is we mount the Arduino on the board, the Arduino and proto board on. So, you know, mount it like that.
Okay, where oh, that's this thing in the center.
And you want the notch pointing to the left. Okay? And I'm not sure that the diagram shows it very well. It just sort of shows them.
Pick this thing up.
In regard to
Yeah, I can barely see the notch on the diagram. I'll point it out to everybody where the notch is. The reason why I went with these cases is because they have an on-off switcher. You want to bring up your Arduino environment and load in the phase2.ino program. Yeah, when you bring it into the Arduino and say import, it'll ask you to create a full sketchbook, and you just say yes. What that chip does in the thing is it is a dual motor controller chip. And the way it's called an H-bridge chip because this is the way we always hook up our motors, motor in the center. And when we want our motor to go forward, we hook across there and there. And the power goes through here, through the motor, like that. And if we want it to go the other direction, we hook it up like this. And now the power goes through there, reverse through the motor, and like that. And that's what an H-bridge chip does. Okay? So that allows us to, using a single battery supply, run the motor either forward or backward.
I see.
The other thing that goes on is, to get speed, we do something called pulse width modulation. So if you want to go slow, we give really thin pulses to the motor, and it just gets a little power and it goes slow. If you want to go fast, we give it really fat pulses, and now the motor goes fast. And that's how it all works. And my intention was to walk everybody through the software, but I'm gonna probably have to walk people through the software at the next class. The biggest problem with these Arduino things is you get a wire wrong and you start looking at it, you just can't see it. Okay?
or it might blow up.
It probably won't blow up. Okay? Now remember to turn your battery packs off. Okay? Because the biggest failure is you show up the next day and nothing works. It's because you left your batteries on all night and it ran the battery down. Okay. Now, longer term, what we want to do is put rechargeable batteries on these things. But for now, we decided to just use good old reliable disposable batteries.
So just open
So
the files
you're working.
Arduino.
So that's what an H-bridge is. So everybody on this table got the software, right? Good.
I don't.
You don't have the software, so we won't let you escape.